Optimization algorithms power fields like logistics, engineering, and artificial intelligence. But designing effective meta-heuristics is a complex, time-consuming process. Meta-heuristics have exploded to over hundreds of nature-inspired variants, many of them small tweaks that never got benchmarked side by side. Handcrafting and tuning yet another optimizer is slow, subjective, and often no better than random search. So we asked a rude question: can a large language model design better optimizers than we can if we wrap it in an evolutionary loop? LLaMEA, our large language model evolutionary algorithm, does exactly that. So how does LLaMEA work? Think of a classic 1 + 1 evolutionary algorithm, but replace the mutation operator with a large language model such as GPT-4. 1. Prompt the model with a task description and a minimal code example. 2. Evaluate the code it writes on an extensive testbed, in our case the 24-function BBOB suite. Third, score performance with an appropriate anytime performance metric, plus record any syntax or runtime errors. Fourth, feedback that information, asking the model to refine or completely redesign the algorithm and iterate for 100 generations. The result? A novel meta-heuristic optimization algorithm outperforming the state of the art. To analyze the capabilities of LLaMEA for black box optimization, we experimented with 9 model strategy combinations using 5 independent runs each, making a total of 4,500 LLM calls. This resulted in 3,657 runnable optimizers. The best performing optimizer, named by the LLM, Irad's Quantum Flux Ultra Refined, is basically a differential evolution with a memory vector that nudges search toward historically good directions, an adaptive mutation factor that grows from 0.5 to 0.8, and a RAN-to-best bin crossover operator. On the full 10,000 evaluation budget in 5D on separate validation instances, Irad's beats vanilla CMA ES and DE, and even surpasses a hyperparameter optimized CMA ES that was tuned by searching over more than 50,000 configurations. 2 more LLaMEA generated algorithms tie or pass that tuned CMA in the first 1,000 evaluation region. Remember, the LLM wrote every line of those algorithms. We never touched the code. The Irad's algorithm doesn't generalize perfectly to 10D or 20D, but other generated algorithms take over the lead for the first couple of thousand evaluations before CMA ES pulls ahead again. That's fine. Each algorithm was evolved for 5D, and the point is that the framework can retarget any setting by just swapping the evaluator. Meaning, with LLaMEA, you can generate optimizers specific for the setting relevant to you. So why should you care? With LLaMEA, you can replace weeks of expert tinkering into one overnight run. Anything with an automated fitness evaluation, continuous, discrete, surrogate-assisted, even machine learning or mathematical formulas can be dropped into the loop. In follow-up works, we have already successfully evolved combinatorial optimization algorithms, Bayesian optimization algorithms, real-world specific optimizers, and machine learning pipelines. Scan the QR code, try out LLaMEA tonight, and tell me tomorrow what algorithm your personal LLaMEA invented.